So, good morning to all of you. In this lecture, I am just going to discuss another very important concept in Hamiltonian dynamics. In previous or in last two lectures, what we have already discussed that how to obtain the expression of H for a time dependent and time independent Lagrangian system. So, with the help of this is our earlier lecture for a given L, how to obtain H. So obtain H for a given L. So this is for given L obtain H. So how to obtain? I have already explained the steps, that by using the concept of generalized momenta which is del L upon del Qk dot is equal to Pk. So replace all Qk's by Pk in this case, and in this lecture I will try to explain, or I will explain that how to obtain the expression of Lagrangian for a given H. So given H obtain L. So how to obtain? We have another important tool, that is Hamilton's equation. In earlier case we have concept of generalized momenta. Here we will use Hamilton's equation, which is del H upon del Pk dot is equal to Qk dot. So replace all Pk's by Qk. Why we are replacing? Because here we will find out L. What is L? Here we have to find out the expression of H. So H is basically function of Qk, Pk and T, and here L is basically function of Qk dot and T. So this is just a one-to-one comparison between L and H. So replace all Qk dot by Pk. Here replace all Pk term Pk by Qk dot. Replace all Pk's by Qk's, means replace all generalized momenta term by generalized coordinate in order to find out the expression of L for a given H. So this is the concept. इस केस में क्या करते हैं? इस केस में जनरलाइज मोमेंटा के कॉन्सेप्ट से सारे Qk's को रिप्लेस कर देते हैं Pk. यहाँ पे हैमिल्टन्स के there are three sets of equation, Hamilton's equations. Out of these three sets, this is very important set to convert our H into L. So using this equation using Hamilton's equation we can convert our H into L. How to? Using, so you can write here, using Hamilton's equation of motion. So using Hamilton's equation of motion we can convert our H into L. So let us see one example which is very important example. The Hamiltonian of a system is given as, and this is the comparison, that how to convert or how to obtain H for a given L. So we have to follow this rule. How to obtain L for a given H, means if we have an expression of Hamiltonian, then how to obtain L. So we have to follow these steps. This is 1 and 2. ये तीन चीजें हमें माइंड में रखनी होगी कि हमें H से L ऑब्टेन करना है तो क्या करना है? L is a function of these quantity, and how to convert with the help of this equation. So let us see this example. The Hamiltonian of a system is given as is given as, which is h equal to p square e to the power minus nu t by 2m plus half m omega square x square e to the power nu t. This is time dependent Hamiltonian, which means del h by del t not equal to 0, so h is not constant of motion, means we cannot write h equal to t plus v. So h equal to corresponding, this is another very important statement question. So corresponding to this h is not equal to t plus v because h is a time dependent. So corresponding to this Hamiltonian, what is L, or obtain the expression of L. So how to obtain? We have Hamilton. So using, so for a given h obtain L using, so we have very important tool, that is, so we can convert our h into L. We can convert our h into L using Hamilton equation of motion, which is del h upon del pk is equal to qk. So in this case we have only profile, we have expression of h is only p and x. So what is our del h upon del p, which is x dot, del h upon del pk dot is qk dot, which is x dot. So what is our del h upon del p? Twice of p e to the power this expression, and this will 0. This will 0. So we have twice of p e to the power minus twice of p e to the power minus nu t by 2m. So this will cancel out, and we have p e to the power minus nu t by m. So what is our p? So this is x dot is basically p e to the power minus nu t by m, which implies that p is simply mx dot e to the power nu t. I hope this is clear to all of you. So this is the way, because what is our goal? Our goal is to convert our h, which is function of generalized coordinate, generalized momenta and time, into L, which is function of generalized coordinate, generalized this is. So anyhow replace all pk's term into qk dot term. So with the help of this Hamilton equation, we can replace our all pk's into qk dot. So which is this one. Now what is our else? We have a relation between L and h. So h is, L is basically qk dot t is equal to pk dot qk dot minus h, qk, pk and t. So using this relation we can convert our L into h and h into L. In this case we will convert our h into L, which is function of generalized coordinate, generalized velocity and time. So what is our L is simply, in this case our pk and qk is p and qk dot is x dot. So this is p x dot minus of h, which is p square by 2m e to the power minus nu t, and this is again minus 1 by 2m omega square x square e to the power nu t. Now we have to replace our p all P by QK dot with this expression, with the Hamilton's. And how to obtain this expression? With the help of this Hamilton's equation. So putting the value of P from here to here. So what we have? We have mx dot square e to the power nu t minus p square means square of this. Let me write one more step. Mx dot e to the power nu t by 2m into e to the power minus nu t minus 1 by 2 m omega square x square e to the power nu t. So this is the, now putting the value of p, now replacing all p's by this expression which contains generalized velocity, that is x dot term. So this 2m, this is m square again cancel out. So what we have? Simply 1 by mx dot square e to the power nu t. This is twice of minus m square x dot square e to the power 2 nu t e to the power minus nu t divided by 2m minus 1 by 2 m omega square x square e to the power nu t. So this will cancel out. This is 1 minus 1 by 2, which is 1 by 2 plus 1 by 2. So we have 1 by 2 m x dot square. This is minus nu t. This is twice nu t. Again become nu t minus 1 by 2 m omega square x square e to the power nu t. So with this we can conclude our L is only function of x dot and t, generalized coordinate, generalized velocity and time. Generalized coordinate, generalized velocity and time, which is the function. So now this is the correct expression of Lagrangian corresponding to this Hamiltonian, and this is the way to find out the expression of Lagrangian for a, whether it is time dependent or time independent. This is the same procedure. So with the same procedure, it's up to, it doesn't matter whether our Hamiltonian is time dependent or time independent. So in this case our Hamiltonian is time dependent, so we have a Lagrangian is also a time dependent. So you, with the help of this Hamilton's equation of motion, we can convert all p's into qk dot, all generalized momenta term into generalized velocity term. In this case x dot is generalized velocity. So with this example we can understand that, or we have already understand that, how to obtain the expression of L for a given h, and there are so many objective questions. So we can also set up the Lagrangian equation of motion corresponding to this equation, and we can also conclude that del L upon del T is not equal to 0. So I think it's all about this problem, which is very important problem. So just go through this problem. So it's all about this problem. Thank you.